Hello all. In this video, you are going to correct the motion worksheet. So in exercise 1, there are three multiple choice questions. Part 1, one object is thrown vertically upward with an initial velocity of 100 meters per second and another object with an initial velocity of 10 meters per second. The maximum height reached by the first object will be that of the other. He needs the proportion between the two heights of the two objects. So, at first, since this example is of free fall, so since the ball is rising in the air or falling, so we take the acceleration as the gravity. So you can always use the gravity whenever the object is falling, so the acceleration is equal to gravity, which is 10. Whenever the object is rising in air freely without friction, so the acceleration will be opposite to the gravity, which is minus g, which is minus 10 meters per second squared. This is always taken. So calculating for the first object, we have the final velocity, of course, 0, since the object will stop at the maximum height. Whenever we throw a ball, it stops before falling. So at the maximum height, always the velocity is equal to 0. So the final velocity is equal to 0. We use the time independent equation. And the initial velocity is given 100. So 0 squared minus 100 squared equal to AD. Acceleration is equal to 10 minus 10 meters per second squared. While calculating in this method, we will calculate the distance d1 for the first object. Similarly, for the second object, we calculate d2, which is 5. Now we need the proportion between the two distances to know the factor by how many times it's greater than it. So we divide the larger distance over the smaller one. So 500 over 5, which is 100 times. So it's 100 times larger than it or higher than it. So it is part or solution B. Now in part 2, a projectile is shot vertically upward. This is the same also. We can take the gravity is equal to minus 10. So with a given initial velocity, it reaches a maximum height of 100. If on a second shot the initial velocity is doubled, then the projectile will reach a maximum height of. So I calculated first the initial velocity at the height of 100 meters. So using time independent equation, taking the gravity minus 10. So V final is also 0 since it stopped before falling at the maximum height. So minus V initial squared equal to ADD is given 100 meters. So by calculating the initial velocity, it will be 20 radical 5 meters per second. I wrote it in the radical form to keep the answer accurate. So for the second object, for the second shot actually, for the second shot, the first shot and the second shot. For the second shot, the initial velocity is doubled, so it will be 40 radical 5, the initial velocity, 40 radical 5. So I calculated here the distance, which is 400 as in solution E. Part 3. A stone is released from rest from the edge of a building roof 190 meters above the ground. Neglecting a resistance, the speed of the stone just before striking the ground. So this means that the stone passed the 190 meters before striking the ground. So the distance is 190 meters. The initial velocity is 0 since it's released from rest. So V0 equals 0. And acceleration is 10 since it's falling, as I said before. When the object is falling, the acceleration is equal to gravity, which is 10. By this, we can calculate the final velocity, which is 61.64. It's closest to solution B. Now, for exercise 2. One day, Bobby, with his bad habit, was texting during driving while he's on speed. Suddenly, he saw an elder crossing the road while he was driving. Bobby was driving his car with a constant speed of, since the speed is constant, so we can easily say it's a uniform rectilinear motion. With the speed 108 kilometers per hour, of course, we should convert this into meters per second. We divide it by 3.6. So from 108 kilometers per hour divided by 3.6, it will be 30 meters per second. At the time when Bobby saw the elder, he was 30 meters away from him. So Bobby's reaction time was 1.5 seconds until he realizes he had to hit the brakes. So Bobby saw the elder, he's moving right now with the URM, uniform rectilinear motion. 1.5 seconds, he said, "Oh, I have to press the brakes." He pressed the brakes. So he moved during 1.5 seconds some distance. Now, when he hit the brakes, he decelerates by 4.5 meters per second squared. Now, calculate the distance covered by Bobby from the instant he saw the elder until he hit the brakes. Okay, so during 1.5 seconds. So since he moved with a uniform rectilinear motion, d equal vt. This is the equation: x equal vt plus x0, or d equals vt. The v equals 30 meters per second, and the time is 1.5. Distance covered is 45 meters. Part 2, calculate the distance covered by Bobby's car in order to stop from the instant he hit the brake. When he hit the brakes, he decelerates by 4.5 meters per second squared. So the acceleration is minus 4.5 since it's deceleration. So the acceleration is minus, this is a trick, minus 4.5. His initial speed was 30 and his final speed is 0 since he needs to stop. By this way, we can calculate the distance needed for Bobby to stop by this deceleration. Okay. Part 3, deduce whether Bobby had hit the elder or stopped. So first, he covered 45 meters in during the 1.5 seconds response time. Then he covered 100 meters in order to stop. So in all, he covered 145 meters, which is much more than the distance separating him from the elder. He was 30 meters away from the elder. So he needs 145 meters to stop. So he will hit the elder and cover about 115 meters more. So he will hit the elder. Now, exercise 3. Two cars are moving against each other. One car A is moving against car B. At instant t equals 0, the first car passes in point A, which is F1, moving at a constant speed URM. After 4 seconds later, the second car is accelerating at 2 meters per second squared, passes in point B at speed of 5 meters per second. So I'll just make this easier. So I'll remove after 4 seconds later. I'll say at the same time. It will be much easier. Okay, so it's a PDF. I can't manipulate it. Okay, at the same time, the second car accelerating at 2 meters per second square passes in the point B at speed of 5 meters per second. Okay. So part 1, write the time equations of motion for each car x as function of time. First, car A is moving with URM, so x equals vt plus x0. V, the speed of A is 23. The initial position of A is 0, assuming that it is the origin. A is the origin. Okay? So the time equation of position of A is 23 t. Now, as for B, the motion is UARM since it's accelerating, so x equal half AT squared plus V0t plus x0. So a half A acceleration minus 2, y minus 2, since it's accelerating to the left. I took the positive axis to the right. Okay, the positive axis to the right. So accelerating to the left. So the acceleration is negative. I don't know if okay. This is the positive axis, and here is the origin. Okay, this is the origin. A is the origin. Okay, so the axis is to the right. Okay, sorry. Okay, the axis, the positive axis is to the right. Okay, and the origin is at point A. This is the x-axis, positive axis. Now, so the A is at the origin, while B is moving opposite to the positive axis. So its acceleration and velocity is negative. So the acceleration is -2, and also the velocity is -5, which is the initial velocity. Okay, and the initial position x0, which is 496, which is away from the origin by 496 meters at start. This is the time equation of position for car B. Number 2, at what instant t would the two cars meet? When the two cars meet, they will have the same position, so we say x equal x. xa equal xb. Using the calculator, this is the equation of second degree. Using the calculator, solving the equation of second degree, we have two roots, two answers, positive and negative answer. Of course, the positive time is accepted. We don't have a negative time. Number 3, at what distance from A would this meeting take place? So we have the time of the meeting. We substitute it in any equation of these two. We'll have the distance separating the distance of meeting. Okay. Last question. Find the initial position for each particle A and B. So this is the xt graph. The initial position is the position of the particle at time 0. At time 0, A was at 300 and B was at -150 meters. Specify the nature of motion since it's an xt graph. Straight line xt graph, it's URM. So both cars are moving with URM since the xt graphs are straight lines. Calculate the speed of each particle. The speed in xt graph is always the velocity, vt. Okay, if we calculated the slope, it's delta y over delta x, so delta x over delta t, which is the velocity. Okay, so the speed, to calculate the speed, just calculate the slope. We know how to calculate the slope for each curve. Number 4, specify the direction of motion. We calculated the speed of A as -6, so it's negative. Since the velocity is negative, we can say that it's moving in the negative direction. Always the velocity refers or tells us about the direction of motion. If it's negative, the direction of motion is negative. If the velocity is positive, the direction of motion is positive. So B is positive and A is negative. The last question, calculate the time and the position when the two particles will meet. When they will meet, similarly as in exercise 3, they will have the same position, x equal x. Mathematically, we will determine and calculate the the time as 32.14 seconds. Okay, I just want to note in exercise 3, why do I want to simplify it? Now here, after 4 seconds later, so we need to include this into the calculation. So we just make the time here, time equation in the in car B as t -4, since the time is 4 seconds later than car A. So it will be t -4 all squared -5 into t -4. It will be more complicated. To run away from this problem, I'll just make things simpler, assuming that the car B reached car F2 reached point B at the same instant. Okay. Thank you so much. Have a nice day.